All right, so when we're going to go ahead and start creating and building this assembly model, the first thing that you guys said you wanted to start with was this base, right? So what we're going to do is we're going to go to the assembly file where we're going to start working. We're going to come over here to the word place, pull down place, and then you have options. Place from content center, that's if we need nuts and bolts and other parts. But we want place because we're going to simply place an object we have from our server or from our desktop or wherever it's saved. So go in, find where you have this thing being saved. So I'm going to go through here to the server. I'm going to get into mechanical. I'm going to get into caster. And now I'm looking at the caster parts. Well, what I'm looking for here is this top plate. Okay, you can call it top plate, or if it's base, the way we're looking at it, that's fine. So we're going to go ahead and hit open. And now this is our base or top plate. I'm going to go ahead and just drop one of these into the assembly. Hit escape, and now I am finished placing the part. Now, what you want to do is you want to orient this in a way that makes sense to the way you're looking at it, okay? So if the assembly you're building is being shown to you in this orientation, then I would flip this base, all right? I shouldn't say flip the base. I would change the view so that the view you are looking at is oriented in the view that you are used to seeing it in, okay? So as I use this cube, you can see that the cube is moving around to different orientations. All right? You want to see it in the same way that you recognize it in your mind. Okay? On this set of drawings, you can see that this is upside down. Okay? From what we have. If this is the way you see to build it, then I would flip it around. You want to have it in a way that makes the most sense to your mind's eye. Now, the next thing we can do is we think about, well, what are the next pieces we want to pull in? So we're looking at them pulling in these next two pieces. This is a side piece. It's called axle support. So I'll go back here to the assembly. I'm going to grab the word here, grab place. And now what I'm going to show you is if I come down, here's axle support. Well, I know I need two of them, okay? I know I'm also going to need this axle. I'm also going to need this bushing. What you can do is hold down the control button. And if I select on multiples and then hit open, you can see that I'm bringing in multiple parts at the same time. So I bring them in, left click, hit escape, and that drops a batch of parts. So it's a way you can bring a bunch of things in all at the same time. All right, as we start going through this, I'm going to show you two different ways to use your constraints and your joints to put this together. This object obviously needs to sit on this part. So what you want to do is think about how they are going to touch each other and how they are going to seat together. So if I look back at the assembly, you can see that the outside edges here are flush all ways around, and that this particular face, if I then hold down my F4, I can do a free orbit around, that this face is flush with this little indentation. So we can use all these relationships of assembly to go ahead and continue to put these together. Okay? Now, as we start putting these together, the faces and what's going to touch what are important to understand. And you have to have a good command of how to turn and move. I will tell you, you have to get used to using free orbit. You can grab the free orbit from grabbing it over here on this view bar, and then it's active. Then you have to right click and hit OK to finish it. Or hold down F4 on your key and you can free orbit. I highly recommend getting used to F4. Okay? You will not be able to do everything accurately with this view cube because it's always going to zoom out. It's always going to be changing and zooming. You got to be able to stay close and zoom and pan. Okay? So, that being said, let's start putting surfaces together. Now, as I do this, I'm going to grab my constraints. We'll work with joints in a second. I'm going to grab my constraint tool, and I'm going to look at this mate constraint first. A simple mate is nothing more than two surfaces, two edges, two axes coming together in one of these two solutions, okay? This solution means that they are in opposition to each other. They're facing each other. This solution means that they are looking in the same direction. Very important to understand what these little pictures mean. These pictures tell you a lot. Make sure you can see them and understand what they're telling you. I want this face to actually be looking at this face, okay? So I'm going to click on this face, and then I'm going to click on this face. It will immediately jump into a position because I have a little checkbox next to these sunglasses that says Show Preview. Then I can use my F4, and I can pan around to see, is that what I want? And you can say, well, sure, that's exactly what I want. So then I hit Apply. I am still in the mate tools, and I'm still able to add mates, but I'm going to hit escape twice just to see what I did. Now, what you can see happening on my screen, if you grab one of your parts and move them, as I am, everything's moving, but this is sliding up and down. I'm going to go to my left view and slide this up and down, but I can't take it away from that face. You can see that they've been mated together. To better understand what mates have been placed, turn it to a different view. Here, it looks like everything is still free, right? But it's really not still free. If I turn it back to this view, I can't take it away from that part. Those two faces that I said go together are together. But it's not just the face, it's the entire plane. Okay? This is a plane. I have not given it any other constraints. I've given it one constraint. 1 degree of movement has been removed. Okay? Now we got to tell it, where do we want to put other constraints? We have to continue to remove degrees of freedom. So let's do it this way. I'm going to grab my constraint tool. I'm going to tell it, I want this face right here to be flush with this face. Now, if I tell it to be mated in this oppositional mate here, I'll just show you what's going to happen. It jumps around this way, and you're like, well, that's not what I want. Why did it jump that way? Well, it jumped that way because it's the only way it can solve that solution. Okay? I don't want it to jump this way. So if I go back and change this and use flush mate, where the two faces are looking in the same direction, just like this old picture shows me up here, then it jumps back into a position that is far more accurate than what I'm looking for. So I'll hit apply, hit escape so I can move my part, and now it's getting closer. I've removed another degree of freedom. Okay? Now, what we need to do is we need to better understand how these are working. We need to ground something, because when everything's moving all over the place, it makes it a little confusing. So I'm going to take, since this is my base, and I'm going to ground the base. Right-click on it after you highlight it and find the word grounded. Once you ground it, you have a pin that will show up when your mouse goes over the part with the universal symbol for grounded. That part will no longer move. You can now see that the arm here is constrained in 2 planes, and it can't move out of those 2 planes. I can slide up and down. So the last degree of freedom that I need to remove with this part is I need to basically attach this bottom face here to this face here. So if I grab my constraint tool, oppositional mate, I select that face, I turn my part, I select this face, they lock together, I hit apply, cancel out of my constraints, turn it just a little bit. If I try and move this, it will no longer move because I have removed all degrees of freedom because it is locked to the base now. If you have added constraints to this, and these constraints have come up with an error, meaning, let's just say we try to do this, and I hit apply, and I get this error. Do not accept the relationship. You must cancel the operation, because what this is telling you is, given the constraints you already have, that cannot physically occur. Okay? So, don't just accept relationships. The other thing is you can always come over here to your browser. Open up the little plus symbols next to all of your parts. And then you can mouse down over top of the constraints that you've placed. And you can see a history of the constraints that are holding the part together. Okay? When you come and mouse over them, you can see the relationship. What was put together, and then of course flush, meaning it's a flush or a mate. Alright, and you can see how it comes together. If your model's not functioning properly, it's probably because one of these mates has not been accurately applied. Okay, this particular operation took 3 different constraints, a mate, a flush, and a mate. Now, we're going to use this joint tool to place this side. To do this, make sure you have the other object, and go back into place. I'm going to come in here and find, that's my axle support. I'll hit open, there's my extra one, and I have it. Okay? So make sure you have that in your drawing. And now what we want to do is I want to pull down the joint tool, and I want to look at the joint tool to see what I have here. Well, first off, the joints, there's multiple types. So you pull down the type button here, and you start looking, and it says you got automatic, rigid, rotational, slider, cylindrical, planar, and ball. Well, we're looking right now at what would be a rigid constraint, the way that we want to put this together. We don't want it to move, okay? So if I select rigid, now I want to select two surfaces. And one of the things you're going to see immediately when you start looking at selecting surfaces is you get a face that highlights, and then you also get this little glyph, or this little symbol, this circle with a dot on it. What this is telling you is two things. One, it's this face, and then it is a specific point on that face, okay? So here, and if I move back and forth, see how that's turning back and forth? That's telling me the plane is either here perpendicular or here parallel to the face, okay? We're going to look and then see what is the options down here. Notice as I move around here, there's all these options. So I have these options jumping around, okay, that I can see what comes together and how it's going to work. So I could look at this face and that corner over there as a connection point. Okay, so let's do that. I'm going to grab that. Well, it says the grounded is selected to move. Do you want to continue? No. I need to select this one first because that's grounded. So I'm going to turn my part. And I'm going to say if I put this together, it's going to be this corner right here. Okay? That corner with that circle. That's going to go together with this corner and that circle. So once I hit this, it then moves it around into position. Okay? So those two faces have been put together. Is this really the way I want this to go together? No. This is not the way I want it to go together. So I'm not going to apply this particular mate. I'm going to cancel this. I'm going to go back. I'm going to find what type of joint is going to give me the relationship. All right, so I got rid of that last constraint. Now I'm going to go ahead and add a new joint constraint here. Grab the joint. I'm going to come down again, rigid, and I want to select this face. But I want this face, when I select this face, I want to have the what would be a perpendicular selection on my plane there. So I grab that. You can see that is now perpendicular to that particular face. Okay. Then I'm going to come over here, and I'm going to find this face, and then I want to move around that little glyph until I get that perpendicular symbol. Okay. The reason why I want that is so I can illustrate a few other things. I'm going to select it, and you can see the movement. It comes and moves into position, but this is really not the position I want this in. So what you can do is with the joint constraint, you can use these tools. This is flip component, and you can invert the alignment. So if I select invert the alignment, well, that just flipped it upside down. Well, that's not totally what I want. Well, let's flip the component or the connection here, and you can see, well, now it's in the right position. So because I selected the two planes, and then I selected that vertical or perpendicular plane, it gave me those options to flip and move things around. These two coming together like this are what aligned everything together, because I basically put center of part and center of base together. I'll hit apply, cancel, and then when I go to move one of these apart, I was able to accomplish what I did in 3 constraints over here in one joint, because it includes multiple constraints or multiple removal of degrees of freedom with that part. So the next pieces you need to put together are going to be these bushings. Now, the bushings can be put in 2 different ways. The constraint tool. Now, the constraint tool can get used. You can use the simple mate, but all the simple mate's going to do is allow you to go center axis, okay, to center axis. So you can do this where you grab center axis and take it to what would be center axis. You can then flip your relationships here so you can get it in position, but all that does is put it together on the axis. Okay, if I apply that constraint, I can just slide it back and forth. So instead of using that constraint, what I like to use with something like this would be the constraint tool, but use the insert constraint. What the insert constraint wants to know is what surface of this part is going to touch the surface of this part. Okay, so here we have center axis will align. This surface or this surface, okay, doesn't matter, one of these 2 surfaces is going to then be in alignment or touching the center axis and surface of this part. So when I put these 2 together, they jump into position, And you can see this bushing would actually be flush and touching this part. Okay? So I'll hit apply and then hit cancel. So this is all done in one mate, but it does lock it in 2 degrees of freedom. Now, this part has actually been inserted into this hole and is spinning. When I hold down my mouse and turn it, it's spinning, but you can't see it. So what we're going to do is we're going to alter this part while it's in the assembly by double-clicking on the part, or you can right-click on the part over here and hit Edit. Either way, double-click on it or right-click and hit Edit in the browser. Either way, the entire model grays out. Everything else in the browser grays out except for that bushing. So now what I can do is I'm going to grab a 2D sketch. I'm going to put it on this face. Okay? Then I'm going to go ahead and grab a circle. Well, actually, I'll grab a line first because I'll position this. And I'll come up, let's come up here 10 millimeters. And at that 10 millimeter point, I'll draw a circle. And I'll make that 2 millimeters. Then I will finish the sketch. And all I'm doing is I'm going to put something here and drill a hole through it. So I'm going to grab my extrude tool. And I'm going to do a negative extrusion through the bushing. Okay? So that I'm placing a hole into the bushing. The only reason I'm doing this, there's no meaning or reason other than I want a hole in my bushing so that I can see the bushing turning as I move the bushing. Okay? What we're going to do is we're going to get back out of the part and back into the assembly. We hit this return button up here. And then when I turn the bushing, if I click on the bushing, left mouse, hold, and move my mouse, you can see that it's rotating in that insert constraint. Okay? So if you use the insert constraint, what happened is the center axes were lined up, center axes are lined up, and then these 2 faces that I selected will not come apart. So the only degree of freedom left is this rotation. All right, so once you have one done, let's go get the other bushing. I'm going to go to Place up here in the top left. I'm going to go find that bushing. So it's in my file structure. There's my bushing. I'll hit Open, and I'll go ahead and drop it in place. One of the things that you'll notice is that that hole is already in this bushing. Okay? All we need to do now is we need to put them together. So I'll grab the Joint Constraint this time. I'm going to tell it I want a rotational constraint. And then I'm going to tell it that this surface, because this is going to be flush, this outside surface here, okay, is then going to be flush with this outside surface here. And because it's a rotational joint, it finds the center axes of this part, so they show up. Now, given that this is not the right relationship that I want, I'm going to go ahead and tell it to change its alignment, or to change this connection to flip the component, okay? Once I get it into the right position, I then hit apply. Now that it's in the right position, I can go ahead and turn this part so I can see that hole, and then I can turn that. You can see that that is the joint constraint coming together. All right, so when we go ahead and put this in, I don't care which constraint you guys want to give a go to, whether you want to use a constraint with an insert, or you want to go ahead and use a joint that is going to be a rotational joint. Either one's going to work for you, okay? But the big thing you want to look for is the relationship between the parts. So if I use this insert constraint, and I'm going to say that I want center axis and this edge of the part right here to then be aligned and flush with this bushing and the edge of this part. It's going to jump into position, but then I want to look at it, and I'm looking at it straight on, and I'm saying this is not right. This should be centered on the part, okay? That's where we're going to come into using this tool called the offset, okay? So what I'm going to do is I'm just going to apply it. I'm going to cancel, and I know that I need to push it over. But right now, I really don't know how far, because I need to center this, okay? So we can do a few things. We can go ahead and put this onto a drawing. So let's just go ahead. I'll then throw this on here to show you what this is going to look like. If I go ahead and, well, I got to save that assembly. Yeah, I'll just drop it in here for now, because I'm not going to end up saving it. And I will then go ahead and start putting this on here so I can see it. So with this assembly, if I drop this onto a sheet, I could easily go ahead and start measuring these things, and then you're also going to see that this is going to update. So I'm looking at 2 millimeters. So obviously if I offset it over 1 millimeter, it would be centered. Okay, so I'm going to go back into my assembly. I'm going to get back into this axle. I'm going to look at that insert. I'm going to right click. I'm going to hit edit. And then I'm going to tell it right now that this offset is going to be 1 millimeter. Okay. And now you can see that I put this in. I have the equal spacing here because I just pushed this over by 1 millimeter. That's one way to do this. All right, so the last thing that we need to put on here is the wheel. So I'm going to go ahead and grab my wheel, which is here, drop this into my drawing. And then what I'm going to do is I want to use the joint constraint. And this time, I definitely still want a rotational constraint, but I want to mouse over this wheel a little bit because I want to find, that's it right there. I want this center rotational constraint, and I want that center surface, that center glyph there to pop up. When that center glyph pops up, then I should be able to come over here and find center of the axle right here. That center glyph pops up. When I select those two, it should move the wheel so it's completely centered on that axle immediately. Now when I turn and look at it, it looks pretty darn centered. So I can hit apply, cancel, and then I'm going to look at that drawing quickly. And now the drawing just updated. You can see that now I'm at 1 inch for that gap, which before I was at 2. I now have a wheel here also. So the nice thing, and I do this all the time, is I'm building. I may build, but I will also build with an active drawing sheet model open, because then I can go in and get real-time information on my part. If I realize that, hey, something's not right here, I can go grab a measurement that I know is incredibly accurate, and then I can come back to my model and do the offsets necessary to make it work. Now, this is an actual wheel that is spinning inside here, but you can't see it. So again, let's get into that part. Now I'm in the part. I'm going to go ahead and alter something in here. I'll go ahead and just throw a circle, and I'll come straight up from center. I'll drop a circle in here. I will negatively extrude it so it goes in the opposite direction so that I can see, return this to the assembly, and then I can see that if I grab this and turn it, you can see my wheel now spinning. Okay. All right, as you see, there's multiple ways to put things together with joints, constraints. Hopefully this was a easy way, or I should say a way that you can follow through and see the differences between the two types.